In the last video, we took a look at this properties of the sampling distribution of p-hats box that we have here. And much like we saw in the section on the sampling distribution for X bar, this box is not something that we're going to have to memorize and be able to kind of regurgitate at any moment, because actually this is all summarized in the formula sheet for this section. If I take a look over here at the formula sheet, I can see that in this last column, everything from that box is listed down. I have my random variable of p hat. It will have a normal distribution if I can check and meet both of these conditions here. Both these checks have to be met to guarantee p hat has a normal distribution. Now, when I think of p hat, remember here that I'm thinking of measuring a percentage of a sample. That's what I'm looking at, a percentage of a sample, as compared to at least the average of a sample that we had back with the X bar variable. Now again, we have some formulas over here for how I find the average p hat, the typical p hat, and that's given by p, and the standard deviation of p hat, which is given by this crazy square root formula. Since I'm dealing with a normal distribution, I'm still going to use commands like normal CDF and inverse normal to calculate things. And I have my z-score formula listed down in case I need that. Now what we're going to do here is take a look and see how this stuff applies as we look at something like example number 2. All right, let's take a look what we have. Suppose that a company claims that 5% of all of their products are defective. Okay, before I even go any further, I should be able to immediately highlight that when we're talking about this 5% here, 5% of all the products made by this company are defective, that's giving me a value of P. It's kind of like how in the last video we said there were 25% of all cards in the deck were hearts. So this is an overall population percentage. Okay, so a company claims that 5% of their products are defective. Now we're going to go ahead and do a random sample of 220 products. We're going to test them, and we're going to calculate what percentage of those, just though that small group of 220 is defective. Now we're going to assume here that this company produces, say, hundreds of thousands of products. Okay, so we're only grabbing a tiny, tiny little portion here. So what we want to do is start right at the top of the formula sheet. We want to define a random variable, state its distribution, and ultimately its parameters. So let's see. We can see here that if we want to grab a sample of products and we want to calculate the percentage that are defective, that is exactly what the variable p hat stands for. It's a percentage of a sample. So I'm going to say, how about we let p hat represent the percentage of the 220 items that are defective. I don't know what this number is going to be, but I can say that p hat is going to be the symbol that stands for it. Okay, so a lot of different p hats could come out of this. If I was to run this sample with my 220 objects and you were to do it with a different 220 objects, we may not get the same percentage back. So again, some p hats are more likely and some are less likely. But what distribution do they have? Well, according to the formula sheet, we know that p hat has a normal distribution, and we know that because or when we actually do these two checks. So I'm going to tackle these two checks. Notice again, I have to do both of them. So I'm going to do check number 1 and check number 2. Both of these checks here technically have like a question mark above their equal sign, and it's our job to figure out if this inequality is actually true. So let's take a look and see what we have. So my first check says that n times p times 1 minus p, is that actually greater than or equal to 10? Well, let's compute it. I can see here that my value of n is 220. That's how many items I'm selecting. My value of p is 5%, or 0.05. So of course, if 5% is p, then 1 minus that 5% would be 95%. Now, if I was to go to a calculator and actually crunch this value out, I could see that the number that I would get back is actually the value of 10.54. And so 45. And so our question is this greater than or equal to 10? And well, very, very clearly we can go yes. Now, this isn't the only check I have to confirm. I need to do a second one. So my second check here is 20 times little n needs to be less than or equal to big N. Remember, big N would stand for the population size. So I'm going to go here and say, well, let's see, 20 times my little n is 220. So that would give me a total value of 4,400. And I'm curious, is that less than or equal to capital M? So again, we took a sample of 220 products, and we know that the company produces hundreds of thousands of products. So I don't know exactly how many, I don't know what capital N is, but I know it's in the hundreds of thousands. So is 4,400 less than a number that's in the hundreds of thousands? Yes, absolutely. So I can check this off. So now I know that p hat does indeed have a normal distribution. And the last thing is state the parameters. So I'm going to state the mean for p hat, and I'll state the standard deviation. Well, again, going back to the formula sheet, I can see that the mean for p hat is always just the value of p. Okay? My value of p is 5%, so this value here is 5%. To get my standard deviation, I have to set up this big square root formula. P times 1 minus p divided by my n, all underneath my radical. So I'm going to end up with p, 1 minus p, remember, is just 95%, and then over 220. And again, I'm going to put kind of the same disclaimer that we did back in the video on x bars, where I'm going to say, let's always make sure that we don't round this value. I don't want to hand a rounded value to the calculator. I'm just going to give the calculator exactly this value to work with. So let's go ahead and try to take this into something like part B. Compute the probability that I would actually go out and find less than 4% of the items in my sample being defective. So if I think about what this means pictorially, I can say, all right, there's a lot of different p hats that I could get. I know that they fall into a normal distribution. I know the most common or the average p hat to get is 5%. And I know that there's a standard deviation of p hats that's given by this value. I don't really know what it is, but I don't want to write out a rounded off version of it. So I'm just going to leave it just like that. Now I'm interested in finding what are the chances that I get less than 4%. So 4% would be like over here on the number line, and I want to go less than it. So I want to find that shaded space. What's the likelihood that the p hat I get is 4% or lower? Well, since I'm looking for a probability, I would say I want the probability of p hat being less than 0.04, and I know I can calculate that with a normal CDF. So it's a normal CDF that goes from -1 E99 all the way up to 0.04, and then I use my mean, and I type in this entire messy standard deviation, the whole thing. I'm going to type all of it in. So this is over 220. So when I have all of that in, then I could go to the calculator and actually crunch this. So I'm going to go ahead and do it right now just to see what I would end up with. Okay, so I'm going to click on second, vars, normal CDF. I'm going to do -1 E99. I'm going to go to 0.04. Average is 0.05. And notice here I'm going to have to do square root 0.05 times 0.95 divided by 220. I paste that, hit enter, and I get a value of 0.2481. Okay, so I get 0.2481. Great, so this is it. Hopefully this feels unbelievably similar to everything we did with normal distributions in the past.